Welcome everyone, it's your boy TechSpace here, and today I'm going to show you how you can make your very own macropad. Now in this video, I'll show you where to find the codes and resources. I'll do a general overview of the code, which is going to be a little dry, so you can skip that if you want. Then I'll teach you how to make your custom profiles as well as custom keypad configurations. Finally, I'll end the video off with a hardware demonstration, and without further ado, let's begin. Okay guys, so this is my GitHub repo. It's TechScape/Arduino Pro macro keyboard. Here I've uploaded all the files and resources that you'll need. You have the 3D CAD files, you have the PCB gerber files if you want to manufacture the PCB. You also have the code over here, the parts list, the required libraries, and a few snapshots of the product itself. Here I have, in the features, I explain like what all the different parts are. I've got the code and usage, how you use it, the PCB itself, as well as instructions on how to solder the PCB because you have to solder it in a certain order, but everything is spelled out here pretty easily. And finally, I've got a 3D printable CAD housing, as well as the different SKUs of it, and optional pieces that you can print out, like the cover piece for extra style points, and the optional transparent acrylic OLED cover for style points. It's over 9,000! Over 9,000! Alright guys, we've come to the part of the video where I explain the general overview of the code. Now this part is a little bit dry, so most of you can just skip on to the next part where I talk about the profiles and how you can set up your own custom keycaps. But for those of you who are crazy enough to go through this, well, good luck. Alright guys, let's get into the code, and don't worry about all these tabs. Don't be intimidated by them because you only really have to bother about the main tab. Auxiliary functions and profile templates, only 3 of them, so don't worry about the rest. And now without further ado, let's get into it proper. Okay, so the first thing I do is import Nico its HID library here. Then I define the shift register variables here. Then I define the rotary encoder variables here. Next, I set up the keypad variables in this section right here. And the first thing is keyboard delay, which I want to go through. And this is basically the delay between key presses. So I've set it to be 160 milliseconds because it's a very nice balance between reactiveness and prevention of duplicate keystrokes. However, if you want your keyboard to be more reactive, you can decrease this number. And if, let's say, you're seeing too many duplicate key presses, then you increase this number. Okay, then we go into the number of profiles and profile names. So you get number of profiles, the number, from the number of items inside this profile names array, and this is done automatically inside the setup function I'll go through later. So basically these names will show up on the OLED display, and if you see here, I've only set up properly defined at least 1, 2, 3, 4, 5, 6, 7, 8 profiles, only 8 profiles here. But if you see in profile names, I have set up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've defined 9 names in here, but I've only got 8 profiles that are properly set up. And I've done this intentionally, hence the name error test as the last one, to show you what happens when you have a missing profile. Alright, next we have the string output of the shift register and what it maps to as button 1. So when K1 is pressed alone, 2 to 3 is the string that comes out. Now where's K1, K2, K3, K4, K5, and K6? They're all in from the PCB. So when I press this switch, the switch that is at position K1, the output is 2 to 3. Now for me, I've defined button 1 to be K1 and so on and so forth for my configuration. But if let's say you want to set, for example, K4 to be button 1, what you need to do is take K4, copy this value and paste it for button 1 here. So then button 1 will be K4. Okay, now I've defined 18 different combinations here, but I'll show you how you can set up your own combinations later on. Next, I have the keypad combination of button 7 for K7, K8, and as well as when K7 and K8 are pressed together. Finally, we define the OLED variables. So in this void setup function, I basically set up the shift register first. Then I set up the rotary encoder as well as the interrupt service routine, which executes when I turn the rotary encoder knob. Then I set the profile selector button as an input, and I get the number of profiles like we mentioned earlier from the size of the profile names array. I begin the keyboard HID library, and then I initialize the OLED display. Then I display the initial OLED UI. Onto the loop function, I basically read the output of the shift register first, then I read whether the profile selector button has been pressed, and then I read whether the rotary encoder switch has been pressed. Now, these two functions, set OLED brightness and invert OLED, these are two functions that run regardless of whatever profile you've selected, and these are to change the OLED brightness, to increase it or decrease it, and to invert the OLED screen. I'll show you what they are later on in auxiliary functions. Moving on, we have a switch statement, which based on whatever profile you're in, your keypad, when you press, it'll, based on whatever profile and what you've defined in a profile, it'll execute whatever it has to execute. If you want to add more cases here, you can just copy paste this and paste it here. Just replace n with the name of the profile or the number of the profile. And if let's say your profile is not defined, it'll throw you an OLED error. Next, we have the function that runs when your rotary encoder knob is turned. And much like the first switch statement, all you have to do is, if you want to add a case for your new profile, you again copy paste this. And the same thing is for rotary encoder switch, which is basically what happens when you press the rotary encoder switch. And if you want to create a new profile, I'll basically run through this later on. Yep. Alright, now we're in auxiliary functions, and the first function is to set the OLED brightness. So what you do is you hold down key 7 and key 8 first, and then you press key 3 to toggle between the brightnesses. What it'll do is that it'll start from the lowest brightness, and then it'll go all the way to the max brightness, and then back to the lowest brightness. Then we go into the invert OLED function, and much like the brightness function, you hold down key 7 and key 8 first, and then you press key 1 to toggle the screen inversion. Then this is the function that displays the OLED error. Next is void OLED UI, and this is the function that controls what you see on the OLED screen. So if let's say you want to move things around, you can just change change this statement right here. And the syntax is your string and then the x and y value of where you want it to be. Then you have the read profile selector switch, and what happens is when you press the switch and it exceeds the maximum number of profiles, which is defined in here, like you get it from this, right? The number of profiles and profile names. If let's say you exceed it, it'll go back to 1 and it'll cycle around like that. And every time you press the button, your OLED UI will update. And this is to prevent the OLED from constantly updating for no reason. The next function is when we want to read the rotary encoder switch when it's pressed or not. Then we have the interrupt service routine for the rotary encoder when you're turning it. And finally, we have the function that reads the shift register. Now you can use this function to set up custom key press combinations. So all you have to do is uncomment this line right here, and I've written it over here as well. Uncomment this if you want to find custom key press combinations, and then you'll be able to set up your own custom key press combinations. I'll go more into that later on as well. Alright, so we move on to the keyboard modifiers and licenses tab. So this is where you'll find the links to APIs and project repos. For example, if you want to find out more about what the keyboard modifiers are, you can just click this link. If you want to download Nico's HID library, it's here. If you want to download the OLED library, it's here. If you want to learn more about shift registers, you can head on to this site from Drone Ball Workshop. And finally, you have my GitHub repo if you want to learn the code, CAD, and if you want to find a PCB to this project. Finally, we have the licenses, which you have to include in every copy of this software. Okay, on to the different profiles. Now, I've set up 8 different profiles over here, and they're all actually very similar. You can either delete or add profiles, and I'll show you how to do that later. I've even got a profile template where you can just copy paste this entire template and then modify it as in how you like. Now the profiles are all, like I said, pretty similar. If you look here, profile 3 R encoder switch action, profile 3 R encoder action, and profile 3 keypad action. If I go to profile 4, it's pretty much the same thing, except the 4 is, the 3 has become a 4. Now this is what the switch statement from earlier, see here, is. This is basically where it goes into, and depending on whatever profile that you're in, it'll execute whatever it has to execute. It's all very easy. You can just modify and change it as and how you like.
Wake up!
Okay, now I'm going to show you how you can create your own profile and how you can create your own custom keypad combination and then implement that into your own profile. So starting with the profile, what you want to do is in the main tab, you navigate down to keypad variables, and in here you'll see the profile names array. What you want to do is you want to add, let's say, a new profile, and I've got 9 already set up, so I'll add the 10th one, and for simplicity's sake I'll just call it profile 10. Okay, then I'll go down to my loop function, and at this switch statement, which controls the keypad input output based on the selected profile, I want to add case 10. Now I've not added case 9 because I want to show you what happens when you're missing a profile and you define the name in the profile names array anyway. So you'll see that in a bit. So over here, when you want to define a new case 10, you can just copy this statement right here, paste, do a bit of formatting, and then call it case 10. Now you will need to do this 3 times, so this is 1. Okay, when you scroll down, you see this function rencoder output. So this is the function that runs when the encoder knob is turned. So here you need to define case 10 as well. So again, just copy paste here, do a bit of formatting, 10, 10, and the last time here, rencoder switch action, which is the function that runs when the encoder switch is pressed. So finally you have it here as well, formatting, and 10 and 10. Okay, then the next step is to go all the way to this tab, profile template, select everything, copy it, and here you see this little drop down button right here. Select new tab, and you can name it whatever you want, but for simplicity's sake I'm just going to call it profile 10. Here you paste it, and you delete the commenting characters, the star and the slash, from the bottom and the top. Okay, and then you change this profile and encoder, rencoder action, and keypad action. You change this to 10 to match the profile that you have just created, and you're done. So now what you want to do is you compile and you check whether there are any errors, and you're good. So you have successfully created your new profile. Moving on to your custom keypad combination. So I've already defined a bunch of keypad combinations in the main tab over here, but if let's say you want to define your own keypad combination, what you want to do is go to auxiliary function here and go all the way to the bottom. I'm already here, and the function you're looking for is read shift reg. This function can be used to set up custom key press combinations. You go down to this line right here, and it says uncomment this if you want to find custom key press combinations. So let's say I want to create a key press combination of, I'm holding down key 7 and 8 and pressing key 5. I don't have that right now. So let's see how we're going to do that. I'm going to upload the code to my Arduino micro. It's going to upload. Usually uploads pretty quickly, and it's done. So now what I'll do is it'll by default print 255, and this basically means that nothing is being pressed. If you see this, everything is okay, it's working perfectly fine. And now I'm going to hold down 7, key 8, and key 5. So now that I know the code is I know the output from the shift register is 244, I'm going to comment this back, and in the profile that we created here, under profile 10 keypad action, okay, so this basically takes the output of the shift register and puts it into a switch statement. So if let's say the case is 244, which we will create, so let's create case 244, which is when I was pressing 7, 8, and then 5. Let's say I wanted to keyboard dot print, let's say success, for example. Okay, I'm going to compile this. So when I press the combination in this profile, this will happen. It's uploading. Okay, done uploading. So now what I'll do is I'll open up a new notepad document right here, and I'm going to press my profile selector switch, go into profile 10. Okay, now I'm going to press 7, 8, and 5, and success. But what you see now is when I press the button just a little bit, even a little bit, success is being printed out multiple times. This happens because I did not put a keyboard delay. Now the keyboard delay here is important because it prevents duplicate key presses, and it slows down, basically, yeah, it just prevents duplicate key presses. I found that 160 millisecond delay is pretty, it's pretty nice in a nice spot, but if you want to make your keypad more reactive, you can decrease this value. If you want to make it less reactive, you can increase the value. 160 is fine for me. So now that we've added the delay, we're going to compile it again and upload it. It's uploading. And we're good. Now I'm going to go back to profile 10. Okay, now I press 7, 8, and 5. Done. Success. And this is how you create your own profile, your own custom keypad combination, and implement that into your own profile. Alright, so here's a layer by layer breakdown of the hardware itself. Right at the top, we have the MX keycaps, followed by the optional OLED and top covers. Then we have the OLED display itself, followed by the PCB cover, then the PCB with all the components soldered onto it, and finally the housing base. You'll be able to find all the 3D CAD models on my GitHub, as well as the PCB Gerber files, and the parts list, as well as the links on where to find them. Okay guys, this is the macropad. I've chosen to 3D print the housing. Let me take you through what are the features. This is the rotary encoder with a knob. This right here is the reset button. You press it to reset the entire Arduino micro. This is the OLED display. This is the profile selector switch. This is the keypad that is connected to the shift register. And on the side here, you have the 10K SMD resistors. Okay, now I'll show you how to change the profiles. So you just press the profile selector switch and you toggle between all the different profiles. If you hold it down, it will just cycle from 1 to 10, which I have set up here. Alright, now I'll show you how you can change the brightness and invert the OLED screen. So you press 7, 8, and 1 to invert the OLED screen. And you press 7, 8, and 3 to change the brightness. Now, I'm not sure if the camera is picking up, but it is increasing the brightness of the screen. Okay, now I'll show you how you can test whether all your keys are working correctly. So what you do is you press the profile selector switch, going to profile 8, and it's called keypad test. Then you open up a empty notepad document, and then on it you press 1, 2, 3, 4, 5, 6. Then you hold down 7 and you go 1, 2, 3, 4, 5, 6, and then hold down 8 and go 1, 2, 3, 4, 5, 6. So when you do the keypad test and you go through the sequence which I just went through, this is what you'll see. 1, 2, 3, 4, 5, 6. Now I'm holding down key 7. 1, 2, 3, 4, 5, 6. And now I'm holding down key 8. 1, 2, 3, 4, 5, 6. So when you're done and all your keypads keys are working properly, you should see, hello world, my name is Textpay, it's nice to meet you, how are you? I am fine, my friend. Alright, now let me show you what happens when you define a profile in the profile names character array, but it's not actually defined. So that's profile 9 called error test, and it's not been defined. So what happens is there's a little error message that shows up here letting you know that the profile has not been defined and there's something wrong with it. Alright, so in summary, we went through where you can find the resources of this project, a general overview of the code, how to create your own profile and custom combination, and finally a demonstration of the hardware itself. Ever since I built the macropad, I've been daily driving it because it really saves me a lot of time, not to mention it's a pretty handy little media control device. Now I've left a small Easter egg for you guys in profile 5, so please have fun with it. Finally, I hope you enjoyed this video. Please like, subscribe, and I'll see you next time.